Okay, today we're out at the Comparison of Biofuel Systems Drainage Water Quality Site south of Ames. This is October 19th, 2020, so we got a little snow on the ground today. At this site we have a few different treatments. We're looking at a traditional corn-soybean rotation. We have two continuous corn rotations where the corn residue is harvested. One of those we also put cover crops, winter cereal rye cover crops down. And then what you see behind me is we have two prairie systems. One prairie system that does not receive any nitrogen fertilizer, and one prairie system that receives about 75 pounds of nitrogen fertilizer per acre per year to try to maximize the above ground biomass. This site was established in 2009, and so this was bulk cropped. In 2009, we came in and put drainage systems in to monitor the individual tile lines. We have 24 individually drained plots at this site that we're monitoring for drainage water quality. At that time, in April of 2009, this prairie was seeded, so a diverse local ecotype seeding of prairie. So we've been monitoring cumulative drainage volume, capturing water samples for nitrate and phosphorus loss from this system for over 10 years now. And so what we've seen is we see where we have this prairie, we see about a 95% reduction in nitrate loss compared to our corn, soybean, or continuous corn cropping systems. And that is with or without the nitrogen fertilizer. So we are seeing nitrate concentrations close to the detection limit for nitrate nitrogen in that water that's leached below the prairie root zone, compared to about 10 to 12 milligrams per liter or part per million of nitrate nitrogen from our annual cropping systems. We do see about a 20 to 40% reduction when we implement the cover crops with our continuous corn system compared to the continuous corn system that doesn't have cover crops. The prairie that you see here is managed similarly from a standpoint of harvest of the biomass. So after first killing freeze, then this biomass would be harvested and quantified for how much above ground biomass might be coming from that prairie system. So that would be something that could potentially be used as part of anaerobic digestion. Some might even use it for bedding for livestock, those types of things. So with that type of system, we would expect to be getting a lot of the benefits that we'd get from prairie, but we are harvesting the biomass in this case. So one of the things to continue to look at is what kind of biodiversity benefits do we get with a prairie that might be harvested versus a prairie that's not harvested. But certainly as we think about the water quality benefits from this, we're seeing dramatic nitrate reduction benefits when we have this prairie out here. I will just comment that we have also looked at phosphorus in the tile lines. We see very little difference, very low levels of phosphorus in the drainage water, and really no difference between the annual cropping systems and the prairie that you see behind me. Okay, here we have our drainage water quality monitoring setup. And so we have each of the plots has an individual tile line at about 3 to 3.5 foot deep down the center, perforated. And that water then comes out one of the large PVC pipes down at the bottom and goes into an individual sump there. And then that water is pumped out of that sump through the flow meter that you see right here. And with that, we capture quantification of how much flow has come out of the plot. We have that hooked to a data logger so that we can quantify on an hourly or time basis how much water is flown out of that individual plot. And then here we have an orifice in here that the back pressure in the pipe forces a small portion of that water into a sample container. So this is a flow weighted or flow proportional water sample, which is really useful for water quality quantification. We get a portion of that water into the sample container, and then once or twice a week we'll come out and collect a representative sample of that so that we can quantify the concentration of nutrients coming out of the plot, and then ultimately quantify the load of nitrate or phosphorus that we're losing with that drainage water that would be going downstream. Okay, this comparison of biofuel system is really a multidisciplinary project. So a number of faculty from agronomy are heavily involved in looking at some of the soil carbon aspects, also just the agronomic management. So Dr. Matt Liebman and Dr. Michael Thompson are actively involved with managing this site. In fact, Dr. Liebman's group is the one that does all the agronomic management of the plots that you see behind me. All right, as I mentioned, this is local ecotype seed that was used to establish this prairie. So this is a tallgrass prairie type system. So the species are what would have been throughout Iowa prior to settlement. And so these systems, you see a lot of above ground biomass, but what's really fascinating is the density and depth of the root structure of these systems, probably extending down 8 to 10 feet for some of the bigger plants that we see here. So, you know, not only a lot of above ground biomass, but a lot of below ground biomass as well with these types of systems. This could be a good choice for biofuels because it does provide a lot of environmental benefits, and it's putting a lot of roots back down into the soil. So over the long term, we would expect that it'd provide some soil health and soil quality benefits as well. While I'm an ag engineer, I would say these types of systems should also provide us a lot of habitat for things like bees as well as monarchs, because we're going to have a lot of flowering plants in here depending upon the species mixture.
Hi, my name is Dan Ciolkosz. I'm with Penn State's Department of Agricultural and Biological Engineering. And we're right here at the university's dairy barn facility, just on the edge of campus. So you see here behind us one of the freestall barns where the dairy cows spend their days, and behind that is the anaerobic digester that we're going to take a look at and talk about today. So here you see one end of the dairy barn where all of the feedstock is being produced, the manure, and that goes across the way over here to the digester. And here you see the large tank there, that's the digester itself. And then the curved roof, that's actually a flexible cover that allows the amount of biogas inside the tank to expand and contract as it's being produced, more or less. You see another little tank there on the left. That's the holding tank or the mixing tank where the feedstock is placed before it's injected into the digester. And then the building next to it, that's where typically you're going to have any controls equipment and the generator that would generate the electricity from the biogas, if that's what you're doing. Typically for manure, you need about a 20 to 24 day residence time of the manure inside that tank in order for it to digest properly. So you've got to think about how much manure your animal is producing, multiply that by the number of animals, and then times 20 to 24. That's going to tell you the volume or size of the digester that you need. And you're going to figure out pretty soon that that's going to be a pretty good sized tank. Prices really vary a lot from farm to farm because the design can vary. The type of system, you know, you can have an in-ground tank versus an above-ground tank, and that all impacts the costs, as well as the electrical generator and the switchgear that's used to transmit the electricity onto the grid. That all has pretty significant cost implications. Digesters are pretty expensive things, and so typically it's going to be more than $1 million is what we've seen here in Pennsylvania for an on-farm digester. If you start combining and getting waste from other locations to add to your farm's feedstock, price is going to go up even more. Economically, it's something that the farmer has to be willing to do themselves. But like I said, it has to be something that you're willing to do. It's not just going to run on its own. You need to be interested in the digester, how it runs, checking up on it out of interest because it takes time and attention to make sure it's running well. The digester is a living system, so just like the cows or swine or crops need attention and care, so does the digester. A digester is going to be a lot cheaper to install if you can use all the energy on site because the various connection equipment is expensive. And you can definitely use the electricity on site. You can use the heat on site. There are a lot of potential uses for that right there on the farm. You even have the potential to take the biogas, compress it, and then use that as a fuel for equipment, you know, for tractors, for trucks, for things like that as a transportation fuel. let's say somewhere around a 500 animal unit digester, you might be able to produce somewhere around 100 to 120 kilowatts of electricity continually from the biogas. And then of course you have the heat that's coming off of that, because the generator only makes use of maybe 25 to 30% of the energy in the biogas and turns it into electricity. The rest ends up being heat. So generating electricity and connecting it to the grid, that's all been worked out. It's pretty standard and straightforward, as long as the utility company is willing to let you do it. If you want to do other things, for example, if you want to take that methane from the digester and inject it into the natural gas pipeline, that's going to take a little more extra effort to upgrade the quality of the biogas that you're producing, and then make the necessary arrangements to allow for that to be used in the pipeline. Anything that a cow can digest, the digester can digest, right? And so you can put crop material into a digester, and it will be digested in there to at least a certain degree. Food waste is an outstanding feedstock. A lot of farmers love to get food waste from nearby processing plants or grocery stores, anything they want to get rid of. That goes into the digester. Naturally, it's very digestible because that's what we eat. We digest that. And so it's a really good supplementary feedstock. Fats. Fats are very high in energy. We know that from our own diet. They also produce a lot of energy in a digester if you have a source of waste fat that you can put into it. The nutrients that are in your feedstock do not disappear somehow in the digester. They come out, and they generally do not come out in the biogas. They come out in the liquid and the solids, the effluent, the digestate it's also called. And so those nutrients are still available and are a big part of the economic value of what comes out of the digester. You definitely want to take advantage of that and utilize those nutrients. If you're interested in possibly having a digester on your farm, the first place to get started is, of course, with your local extension agents, to talk to them, find out if there's another farmer nearby that you can go take a look at their operation. See if you can get a feasibility analysis. There are a lot of programs through USDA and through Extension that can help you answer some of those first questions to see if it's just a good idea, or is it a good idea that's actually going to work for you.